expression for angular momentum in Cartesian coordinate. Dear students, we know that in the force analogous is torque. Okay, force analogous is torque, which is the rotational effect of force. Similarly, there is analogous of linear momentum, and that is known as angular momentum. Now, by Newton's second law of motion, we have expression F is equal to dp by dt, where p is the linear momentum. If by somehow we can express torque, right, torque in terms of derivative of some quantity, suppose that is L, in that case that L will be known as the angular momentum. Now we need to find out the expression for this L. Now we know that torque is equal to xfy minus yfx. Okay, so give it number 1. Now since we need to find out expression in terms of momentum, so we'll use the expression for momentum. Let px is equal to m vy and py is equal px, sorry, here it is mvx, and py is equal to mvy. Now if we find an expression, f is equal to dpx, fx is equal to dpx by dt, so that is m, which is equal to m dvx by dt. Similarly, fy is equal to m dvy by dt. Now putting this value in this expression, we will be having torque is equal to x m dvy by dt minus y, this is fx, m dvx by dt. Now taking m common, so we get x dvy by dt minus y dvx by dt. Now you can again see that this torque is not in terms of dl by dt. So what we have to use? We have to use the identity of differentiation, which is d by dt of xvy minus yvx. Okay, xvy minus yvx. When we will solve it, so differentiation of x into dvy by dt, okay, and that is equal to, firstly we will differentiate this term plus vy into dx by dt, then we will differentiate this term, this is y dvx by dt. Since my negative sign is there, so again negative, this is vx into dy by dt. Okay, so that comes out to be x dvy by dt plus vy, this is vx, right, rate of change of displacement along x-axis is vx, minus y dvx by dt minus, this is again vx vy. So this will cancel out and we are left with x dvy by dt minus y dvx by dt. So putting this value, instead we will write this. Okay, so we are having torque. So we are having torque is equal to mx dvy by dt minus y dvx by dt, and we have used the identity d by dt x vy minus y vx is equal to this one. So instead of this we will put this expression. So torque is equal to m, and instead of this we will write d by dt of x vy minus y vx. Now taking m inside, that is equal to d by dt of x m vy minus y m vx. So that is d by dt, this is x py minus y px. Okay, so this is torque. Now we have expressed torque in terms of rate of change of some quantity. Let that quantity is L. So torque is equal to dl by dt. So this L is equal to angular momentum of the particle particle and is equal to L is equal to xpy minus ypx. This is the expression for angular momentum in Cartesian coordinates.